Hello students, in the last class I gave you some questions to solve as home assignment. I hope you must have solved them. The questions were: prove by mathematical induction that 1 plus 2 plus 3 plus n is equal to n into n plus 1 by 2 for every n belonging to n. Second question was: prove that 3 raised to 2n plus 2 minus 8n minus 9 is divisible by 8 for all n belonging to n by principle of mathematical induction. Third question was: prove that x power 2n minus y power 2n is divisible by x plus y for every n belonging to n. Let us see the solution of one of those questions. First one was 1 plus 2 plus 3 plus n is equal to n into n plus 1 by 2 for every n belonging to n. First we examine p of 1. 1 is equal to 1 into 1 plus 1 by 2. Obviously, 1 is equal to 1, therefore, p of 1 is true. Let p of m be true. So, p of m can be written as 1 plus 2 plus 3 plus m is equal to m into m plus 1 by 2 for every m belonging to n. Take this statement as first equation. To prove p of m plus 1 to be true, we will have to prove that p of m plus 1 is 1 plus 2 plus 3 plus m plus 1 is equal to m plus 1 into m plus 1 plus 1 upon 2 for every m belonging to n. This, using the first equation, could be simplified as p of m plus 1 can be written as 1 plus 2 plus 3 plus m plus 1. As we have already an expression till m 1 plus 2 plus 3 plus m, this could be written as m into m plus 1 by 2 plus m plus 1. Now, taking m plus 1 common, we could simplify this as m plus 1 into m by 2 plus 1. On taking LCM, we can write it as m plus 1 into m plus 2 by 2, which again can be expressed as m plus 1 into m plus 1 plus 1 upon 2 for every m belonging to n. That implies p of m plus 1 is true. Hence, the result is true for all n belonging to n. Now, we should solve a question using mathematical induction to prove the rule of exponents a b whole raised to n is equal to a power n into b power n for all natural numbers n. For the solution, we can take let p n be the statement, a b whole raised to n is equal to a raised to n into b raised to n. P of 1 means a b whole raised to 1 is equal to a raised to 1 into b raised to 1. That is, a b is equal to a b, which is true. That implies p of 1 is true. Let p of m be true, that is, a b whole raised to m is equal to a raised to m into b raised to m. Take this equation as number 1. For p of m plus 1, a b whole raised to m plus 1 is equal to a b raised to m into a b raised to 1, which could be simplified as a raised to m into b raised to m into a b using the first equation, and this again can be expressed as a raised to m into a into b raised to m into b. Here we are using laws of exponents. When the bases are same, you can add the powers. So, it can be expressed as a power m plus 1 into b power m plus 1. That implies p of m plus 1 is true. Hence, by the principle of mathematical induction, p of n is true for all natural numbers n. Students, you must have enjoyed the questions we have solved till now, and you will find in your textbook similar questions based on sum of the series, inequality, divisibility and exponents. I am sure you will be able to solve them with the help of these questions which you have learned. Now, we have one more example which is involving inequality. Look at this. Using induction, prove that 2n plus 7 is less than n plus 3 whole square for every n belonging to n. For the solution, let Pn be the statement 2n plus 7 less than n plus 3 whole square. Now, P1 means 2 into 1 plus 7 is less than 1 plus 3 whole square. On simplification, we get 9 is less than 16, which is obviously true. Therefore, P of 1 is true. Let P of m be true, that is 2m plus 7 is less than m plus 3 whole square. Take this equation as number 1. For P of m plus 1, we can write 2 into m plus 1 plus 7. That can be simplified as 2m plus 7 plus 2, which is less than m plus 3 whole square plus 2. Again using the first equation, this on expanding we get m square plus 6m plus 11, which is obviously less than m square plus 8m plus 16. Note this step, it is very important here because 2m plus 5 is greater than 0 for every m belonging to n. We could put the inequality sign with the help of this expression. Therefore, this implies 2 into m plus 1 plus 7 is less than m plus 4 whole square. This implies P of m plus 1 is true. Hence, by principle of mathematical induction, P of n is true for all n belonging to n. Let us take one more interesting example. It is very challenging. Use principle of mathematical induction to prove that n into n plus 1 into n plus 2 is a multiple of 6 for all n belonging to n. Here you are supposed to frame the statement also, that is, let P n is equal to n into n plus 1 into n plus 2. For step 1, n is equal to 1, P 1 is equal to 1 into 1 plus 1 into 1 plus 2, that is 6, which is obviously a multiple of 6. Therefore, the given result is true for n is equal to 1. In step 2, assume the result is true for n is equal to k. Therefore, P of k is equal to k into k plus 1 into k plus 2 is a multiple of 6. Therefore, let k into k plus 1 into k plus 2 is equal to 6 m. Take this equation as 1, where m is an integer. To prove P of k plus 1 to be true, we can write P of k plus 1 as k plus 1 into k plus 1 plus 1 into k plus 1 plus 2, which again can be simplified as k plus 1 into k plus 2 into k plus 3. Again taking common k plus 1 into k plus 2 plus 3 into k plus 1 into k plus 2. We have this as 6 m plus 3 into k plus 1 into k plus 2. Here we are using a property in algebra. Since k plus 1 and k plus 2 are two consecutive numbers and product of two consecutive numbers is even, we can write this expression as let k plus 1 into k plus 2 is equal to 2n for n belonging to n. Therefore, we have P of k plus 1 as 6 m plus 3 into 2n. This gives us 6 m plus 6 n. Taking 6 common, we get 6 into m plus n, which is clearly a multiple of 6. Therefore, the result is true for all n is equal to k plus 1. The result is also true for n is equal to 1. Hence, by principle of mathematical induction, the result is true for all n belonging to n. So, students, we have done many questions based on inequality, divisibility and sum of the series. I hope you will be able to solve the other questions given in your textbook. Now, it is very interesting to have some of the challenging questions with us. You can take down and you can try them on your own. Question number 1. Prove by mathematical induction that the sum of the cubes of 3 consecutive natural numbers is divisible by 9. And second challenging question is, prove by induction that 4 plus 8 plus 12 plus so on plus 4n is equal to 2n into n plus 1 for every n belonging to n. Here I think you have seen that this is a multiple of 4. It is a series which is having sum of all multiples of 4. I hope you can try and you will be able to do it successfully. So, students, in algebra or in other branches of mathematics, there are certain results or statements that are formulated in terms of n, where n is a positive integer. To prove such statements, the principle of mathematical induction can be used. Thank you.